students, welcome to the channel. So today in this video we are going to discuss some questions with their brief explanation. So let's have first question. Green bones are being used commercially as a source of, and the options are option A type A gelatin, option B type B gelatin, option C both, or option D none. So green bones are being used commercially as a source of. The correct answer is type B gelatin. So green bones are being used commercially as a source of type B gelatin. Let's discuss with explanation part. So it is a chart which is showing that the which type is gelatin and the source of that and the treatment and their isoelectric point. So talking about the type A gelatin, the source of type A gelatin is acid bone and the treatment is acid, where the isoelectric point of type A gelatin is 7 to 9. Students, many a times the question asked that in competitive exams that which is the what is the isoelectric point of the type A gelatin or type B gelatin. So talking about the type B gelatin, that the source of type B gelatins are green bones and the treatment is with alkali, and talking about their isoelectric point is 4 to 7, where type A gelatin is having 7 to 9. So the correct answer is type B gelatin. So it's all about this question. So moving on the next question, that Bissler-Napier-Ski synthesis is performed for the options are option A isoquinoline, option B thiophene, option C quinoline, and option D pyridine. So Bissler-Napier-Ski synthesis is performed for the synthesis of isoquinoline. So let's discuss with the explanation part. So it is an intermolecular electrophilic aromatic substitution that allows the cyclization of beta-aryl ethyl or beta-aryl ethyl carbamates. So the reaction is most notably used in the synthesis of dihydroisoquinones, which can be subsequently oxidized to isoquinones. So the question arises that what is the Bissler-Napier-Ski synthesis, which for which compound? So the correct answer is isoquinoline. Students, you have to just learn this, that Bissler-Napier-Ski rule is for isoquinones. So let's have a look on the reaction part, that it is a reaction where with the help of ZnCl2 the isoquinoline formed. So it's all about the Bissler-Napier-Ski rule reaction. So moving on the next question, drug of choice for lithium induced nephrogenic diabetes insipidus. So the options are option A spironolactone, option B desmopressin, option C amiloride, and option D hydrochlorothiazide. So which is the drug of choice for lithium induced nephrogenic diabetes insipidus? So the correct answer is amiloride. Amiloride is the drug of choice for lithium induced nephrogenic diabetes insipidus. So let's have a look on a brief explanation, that spironolactone is the drug of choice in hyperaldosteronism, where desmopressin is used in central diabetes insipidus because it is more V2 selective, where amiloride is the drug of choice in lithium induced nephrogenic diabetes insipidus. So hence the correct answer is amiloride, where hydrochlorothiazide is used in heart failure, hypertension, or edema. So the correct answer is amiloride. So moving on the next question, that SDS page experiment is, and options are Option A, immunoblotting. Option B, chromatography. Option C, electrophoresis. Option D, none. So the correct answer is that SDS page experiment is about of electrophoresis. So let's discuss in brief here. SDS page means SDS means sodium dodecyl sulfate. Page means polyacrylamide gel electrophoresis. So SDS page is about electrophoresis. So let's discuss in detail that it is a variant of polyacrylamide gel electrophoresis, and SDS page is an analytical method in biochemistry for the separation of charged molecule in mixtures by their molecular mass in the presence of electric field. Means there is a separation of charged molecules based on the molecular masses by applying the electric field, and it uses sodium dodecyl sulfate means SDS molecules to identify and isolate protein molecules. So SDS plays an important role in the separation of the charged molecule. Let's have a look that how SDS page plays an important role. Students, with the help of a schematic diagram, here we have a just schematic diagram with the in which the first step is that denaturation with the help of sodium dodecyl sulfate. And sodium dodecyl sulfate is an ionic detergent that binds stoichiometrically to number of peptide bond and leads to the separation of separates on the basis of size or molecular weight, where in second step we just place the mixture of protein on gel and apply the electric field. So there is a separation on the basis of that there is a separation of protein on the basis of charge and the direction of migration, and where the decreasing size is just having an order of in third step we just stain to visualize separate bands with the help of detection techniques. So it's all about the SDS page. So hence the answer is SDS page is about electrophoresis. So let's move on the next question, that the range of the fingerprint region in IR radiation is, and the options are option A 4000 to 3000 centimeter inverse, option B 4000 to 1400 centimeter inverse, option C 1400 to 600 centimeter inverse, and the option D 900 to 600 centimeter inverse. So the correct answer and the range of fingerprint region and IR radiation is 1400 to 600 centimeter inverse. So let's discuss in detail about this. That first of all we have to know about that what is fingerprint region. So fingerprint region is that the region between 600 centimeter to 1400 centimeter in an IR spectrum is known as the fingerprint region. Students, just try to note down that the region between 600 to 1400 centimeter inverse is known as fingerprint region, and it usually contains a large number of peaks. Means in this range there are large number of peaks, making it difficult because there are large number of peaks, so it is quite difficult to identify individual peaks. However, the fingerprint region of a given compound is unique and therefore can be used to distinguish between compounds. So let's discuss that how just fingerprint looks like with the help of schematic diagram. There is a comparison of schematic diagram that this is the fingerprint region. As we already discussed that there are different so many peaks, so more difficult to identify the compound, where in comparison to others, that in the functional group region, that is 4000 to 1400 centimeter inverse, that there is a specific peak at 360 3600 of OH peak. So it's It's that hence, so the correct answer is the fingerprint region is about 1400 to 600. I hope that the doubt is clear about the fingerprint region. So hence the functional group or diagnostic region is used to determine the functional group present, and the fingerprint region is used for structure elucidation by spectral comparison. So it's all about this question and the fingerprint region. So the correct answer is fingerprint region, that is of 1400 centimeter to 600 centimeter inverse. So moving on the next question, that xylitol is useful in the treatment of asthma because it, and the options are, inhibits prostaglandin biosynthesis, inhibits leukotriene synthesis, option C inhibits leukotriene receptors, and option D inhibits lipoxygenase. So what is the function of xylitol and what is the mechanism of action in the treatment of asthma? So the correct answer is it inhibits lipoxygenase. So how will it inhibits lipoxygenase? We will understand with the help of flow chart. So let's have a flow chart of this. First of all, we have to know about the xylitol. That xylitol is an oral active inhibitor of 5-lipoxygenase, thus inhibits leukotrienes LTB4, LTC4, LTC4, LTD4, and LTE4, and the formation of the formation used for the maintenance of treatment of asthma. How it is helpful? Let's have a brief description. That it prevents the arachidonic conversion to become an leukotriene. So hence it just inhibit the conversion of arachidonic acid to leukotriene. So the correct so it inhibits 5-lipoxygenase, that is that arachidonic acid, with the help of 5-lipoxygenase it converts into leukotriene. So it inhibits lipoxygenase, and when the lipoxygenase ultimately inhibit, so there is no formation of LTA4, that is leukotrienes. So, and what about the zephyrleucast? Actually it inhibits LTC4, LTD4, and LTE4, that is leukotrienes, to bind their receptors. So this is the mechanism of zephyrleucast and xylitol. I hope the doubt is clear, students. So moving on the next question, drug which is used for treatment of smoking cessations, and the options are, option A is vernicillin, option B is acetylcholine, option C is acetylcholine, and option D is tacrine. So the correct answer is vernicillin is the drug which is used for treatment of smoking cessation. So let's discuss with the help of explanation that it is a prescription medication used for smoking addiction. Those who are having the addiction of the smoking, so they are just given with a vernicillin as a prescription of medication, and this medication is first approved nicotinic receptor partial agonist specifically, and the vernicillin is a partial agonist of the alpha 4 and beta 2 subtype. Students, just try to note down this, of the nicotinic acetylcholine receptors. So it's all about the vernicillin, and it is a marketed formulation that we are just having, that Champix, and the film coated tablet, that is of vernicillin, which is used for the smoking cessation. Next question is 5-methyl-3-phenyl 4-isoxazoyl penicillin is, options are, option A oxacillin, option B cloxacillin, option C dicloxacillin, and option D amoxicillin. Students, don't try to just afraid from these types of question, because if you just see the question, it is very simple to attempt, and we just explain with the help of the structure. First we have to identify that which is the correct answer. So the correct answer is oxacillin. 5-methyl-3-phenyl 4-isoxazoyl penicillin is oxacillin. Let's discuss with the help of structure, how it is. So the structure of oxacillin is, so let's discuss that. Students, this is a penicillin structure, basic penicillin structure. We have just know that it is a thiazolidine ring. We just denote with the help of T, and it is a beta lactam ring. We just denote with the help of beta lactam ring. So let's discuss that 5 methyl. The 5 methyl, it is based on it is on 5 position. 5 methyl 3 phenyl means here is it is a 3 position and it is a phenyl, and 4 isooxazole means it's in 4th position, 4 isooxazole, and it is complete penicillin ring. So the hence the correct answer is oxacillin, and its name is 5 methyl 3 phenyl 4 isooxazole penicillin. I hope student your doubt will clear from this structure, that how will the IUPAC naming actually occur by this structure. So moving on the next question. Scamonin is the chief active constituent of, and the options are option A tragacanth, option B jalap, option C colophony, and option D both B and C. So scamonin is the chief active constituent of jalap. Let's discuss with the help of brief explanation that tragacanth having the chief constituent is tragacanthin and basorin. So just try to note down their chief constituents, where jalap having scamonin of as a chief constituent, which is the correct answer, and the colophony having the chief constituent is abatic acid and racine. So it is the correct answer is jalap. So moving on the next and last question, that identify the correct sequence with respect to inductive effect, and the options are option A is CF3 is greater than CH2 F, and these are the options. So identify the correct sequence with respect to their inductive effect. So according to the inductive effect, the correct answer is B, and let's have a explanation on this, that as electron withdrawing substituent is greater in CF3 means CF3 having more electron withdrawing substituent means that is fluorine. Fluorine is having the capability to withdraw the electron. So it is based on the withdrawing capacity, and it is more stable, and CH3 is the least stable on 1, and hence the sequence is B, and the correct answer is B. So it's all about this video. Thank you.